producing locks now, so we're officially in the lock making business. So that's going to be the primary focus of this particular video. The first lock that we've decided to make is a round-faced English styled lock from the 1760 time frame. So a lot of these locks were sent over here, imported to the colonies, and are appropriate on American long rifle, colonial long rifle, as well as English guns. This is an example that's been polished and engraved. It's the same lock that I just showed previously. So one thing I'd like to focus on is how we make these locks and what makes them different and better than currently available locks. First of all, I think we'll just focus on how we make the locks and kind of compare and contrast that to how locks have been made for the last 50 years in the modern era. So traditionally, in the last 50 years, locks have been made using primarily investment castings. About the only parts that are machined are the screws. And this is, the track record is that it's worked very well. And investment casting allows parts to be made that are kind of an unusual shape in a cost-effective manner, and it's worked. But there's better ways of doing things, and the technology has progressed to a point today where there are other options other than investment casting, options that can produce a part that's much better than those from investment casting, particularly on working parts that interact with each other, such as the internal parts, the tumbler and the sear and the bridle and even the plate. The locks traditionally have worked well for the past 50 years, but they also cause frustration amongst those that understand what a lock should be. And it does take a lot of time to try to make a lock function as well as it can be, and a lot of times you never really can get there, just because of what you're starting with. So the whole idea with this was for us to try to move things forward, produce as high a quality product as we can at still an affordable price. So this is our first model. You can see the internals here. And there'll be more models to come as well. So what you're looking at here is a lock that is made primarily from machined parts. The plate is all machined. So the plate actually starts out with a chunk of metal like this. You can see there's a lot of material removal. That's time and that's money. However, the plate is sort of the foundation for all the other parts. Other parts reference off the plate have to fit well. So we've opted to machine the entire plate, even though it's a difficult part to machine, because it's required to get the quality level that we want. In addition to the plate, the sear is 100% CNC machined, the tumbler, the bridle, the sear spring, the main spring, the frizzen spring. The castings we use are the frizzen, the cock, and the top jaw. However, even the frizzen, all working surfaces, all critical surfaces, are either ground or machined. So it basically has all the precision associated with a fully machined part. Traditionally, castings were assembled largely without the use of cutting tools. Tumblers were turned on their axles. Besides that, belt grinders were used an awful lot, or have been, or currently used an awful lot in the assembly of parts from castings. And although it works, it doesn't work as well as it could. In the process of developing this lock, we've studied many examples of original locks from the period and consulted with experts in the field today. In particular, Frank House has been very helpful in giving his critique, and it's allowed us to produce a product that's much better than it would be if I just tried to make it alone. So basically every detail in terms of the design has been mulled over. It's not a copy of any particular one original lock. What we think, it combines a lot of the best features of locks of the period. So a whole bunch of details is what these locks come down to, and to try to think of all the details and mention all the details in a video is very, very difficult. And these details are not only in terms of design, aesthetic design, but also in design in terms of function, and also how the process that's used to make them and the precision. So there's a lot of aspects. You know, flintlock is a very complicated item, and there's a lot of aspects to cover. But all these details add up, so I'll point out just a couple details. As you can see, this is the bridle. So the bridle, I'll point to it on the finished lock example. The bridle is this piece here. So what it does is it supports the tumbler and the sear, and it acts as a bearing point for the tumbler as well as the sear. On good quality English locks, they pretty much always were located with pins. Screws are not good locating features at all, but modern made locks, almost all of them are just located with screws. I don't know of any that have bridles located with pins, which is kind of a poor way to put the locks together. We want to make them as good as the best original locks. So here's an example. You can see the locating pin here and the locating pin right there. So that positions the bridle on the plate, and it does not rely on screws to position the bridle. So I can show you how it goes in place. There to there, there to there. It fits perfectly flat against the plate, and it also gives a lot of support to the lower side of the bridle. And I also mentioned a little bit of design, is that this is a very classic bridle shape. It originated as a French design in the 60s probably. Persisted, and the English used it a lot. You see some locks have a lot of other stuff going on with the bridle, and I think it looks terrible. Classic shape of a bridle, just fits perfectly and looks great. We're working with a very good company to produce screws for the locks. They can hold dimensions to within a 1/2 thousandths if we need that. Again, it's just all part of each little component adds up into a great product. Moving forward to the tumbler, again, it's all machined, no castings are used. Machining allows the notches to be made very, very precisely and carefully. You can feel it in how the lock functions. Very consistent, no handwork. The sear is also all machined, so the shape of the tip that interacts with the tumbler notch is very controlled, as is the hole size and the thickness. Pretty much every dimension of the lock where internal parts are concerned, it's held to just a couple thousandths, probably plus or minus a thousandths, maybe some parts maybe plus or minus 2 thousandths, but this is probably 10 times what locks made with castings and belt sanders are held to. The frizzen spring, this is even all machined. No flat stock that's bent to kind of simulate a spring used here. This is very representative of original work. No shortcuts taken. The mainspring as well, highly detailed, nice bevels. And again, it's all machined. It results in a spring that's very, very consistent. A spring that's straight, doesn't rub on the plate, isn't a mile away from the plate either, and works very, very well. And it will end up being more reliable than a cast spring. Castings are prone to have defects, internal flaws, and even the frizzen spring has been all machined. Even the details on the finial. So it really is quite remarkable what can be done with the CNC technology. It's not easy, but it can be done. You can even see the offset on the bottom to allow the finial to fit perfectly against the plate. No big gaps like you see so often. What we call the rest position, the half cock position. Notice the nice straight lower limb of the mainspring, and when you look at it from the front side, there's a nice balance between the angle of the frizzen and the angle of the cock. Full cock position, you still see the nice straight lower limb of the spring. This spring has also been designed such that there's a let off at the full cock position. So what that means is the force that's required to move from half cock to full cock position is less than say from rest to half cock, and that has to do with the spring's design and the tumbler's design as well. And that's a characteristic of a very high quality lock. The spring doesn't tend to load up. And on other locks that are available, the springs tend to load up an awful lot. We machine the entire spring. It's not an easy part to make, but machining makes the part very, very consistent. Every spring is going to be very close to within a small tolerance. Springs are part of the mechanism, and the mechanism we want to control. So as I mentioned, the frizzens, the cocks, and the top jaw are castings, but even the frizzens are machined on all the critical surfaces. So, kind of explain here, both sides of the foot are machined, the inside face is machined to control this size. The bottom, the cover of the pan is surface ground. And even the toe of the frizzen that rubs on the frizzen spring, it's even machined. And all these are done, basically the majority of everything's done in one operation, so it's all very consistent and it just fits with the lock plate. This results in locks that have parts that are truly interchangeable. So in these locks here you see that, well, maybe you might be able to see and you might not, that there is no fly in this particular lock. These locks that I've been showing you are locks that are going to go in our kits. Our kits are set up for single triggers only, so there's no need for a fly. But on locks that we're going to be selling individually, there will be a fly in the tumbler, so you can use those with set triggers if you would like. Another very important part of or important benefit for the CNC machine locks for us is the fact that we can use them in our rifle kits. We will be selling these as individual components, but they will be standard on our kits. Currently, they're standard on our Colonial kit. The advantage of controlling the size very close is very helpful with regard to our kits. Our stocks are CNC machined, and to have parts that are produced in other ways, less exacting ways, it makes it much more difficult to fit the parts to the stock. So using a lock from castings and fitting it to the stock is more involved. So we want to try to keep improving quality of our products, of our kits, and part of that is to keep machining more and more parts. So here's an example of a stock that in our Colonial rifle kit, and this is the inlet. And the great thing about this is the inlet is cut with CNC equipment, and the lock itself is machined with CNC equipment, so they can fit without any work and just be a perfect fit. No gaps whatsoever. And in addition to the fit being great around the edge, the bolster thickness, that is the distance from the bolster to the inside of the plate, is controlled very closely. The bolster is parallel to the inside of the plate, which is very critical for everything to go together. And we even have on the locks that go with the kit, we even have the bolt holes drilled for the lock bolts. So, some common problems that you'll find on currently available locks. I mentioned plates that aren't flat. That's a big problem. It's standard course when I was building custom rifles to have to straighten lock plates, and you really don't think that should be. The bolster not being the same distance from the plate, not being parallel to the plate. Again, this is all done with belt sanders, and it's just not controllable. Another problem that we see a lot are sear screws that can't be tightened because the bridle will pinch on the sear, or mainsprings that rub on the plate, or sear arms that rub on the plate, big gaps between the internals and the bridle and the plate. It's been accepted for years that you buy a lock, and then people that want quality have to then go through, and it's called tuning up a lock. But it's just basically another way to look at it is just fixing up mistakes that the original manufacturer never made correctly. And we don't want to do things that way, and we're not going to do things that way. When we produce a lock, it's going to be as good as it really can be, as we feel it can be made, and we'd recommend you not try to tune it up. So kind of to summarize, we're very excited about this next new step in our business in making flintlocks. It's been a challenge. It's been very difficult, to be honest. We've put a lot of money, a lot of time, and a lot of resources into it, but we're excited to come up with a great product. And like I said, we'll be adding to the lineup as time permits. We're working on new models right now. Check out what we have to offer, and please ask any questions. The interaction is very good. And a part of this, the reason for this video, is to offer information and explain about our locks and what makes them different, and why that's important. So a conversation is very good. Don't hesitate with any questions. Thanks.